And how does AutoML deliver, right? We have our proprietary way of doing AutoML and a lot of other stuff we wrap our capability with. But fundamentally, because this is a conversation about automated ML, driving actions, over the years, we've just simplified it into these four model classes, if you will, or these four ways to think about at a macro level use cases in machine learning and AI. First, let's start with the data, right? We'll talk a bit about our automated data prep and data detailing a little later in the slides. But fundamentally, the automated machine learning I'm talking about is supervised machine learning on structured data. So supervised machine learning is where we're learning from historic labeled data of the past to be able to score, probabilities and predict on new data we haven't seen before and use that to guide action into the future. And so we'll talk a little bit later about some sample data and we'll go through some use cases. But fundamentally, the data types we support are things like strings, where we can do interesting natural language processing on those strings within the structured data, enumerated values, integers, reals, dates, and we can process that data either in batch or in real time. And so what are we taking this data and doing with it? These model classes in automated machine learning, when we're talking from a supervised perspective, are classification, regression, and forecasting. So binary classification, if we focus on the two buckets in the upper left there, refers to the ability to predict entities and their outcomes across two classes. So for example, perhaps you have data, again, about, let's say, churn customers, where you can learn from that data and predict the probability of a customer to be to churn or not to churn, or a lead to convert or not convert, an MQL to move to an SQL, an SQO to move to an SQL, an SQL to move to ACV. So you can predict these binary outcomes. Will the ad get a click, right? Will there be a particular response? That type of outcome in two classes is served through binary classification, which is the type of model class. So we support that using whatever data you want to. Multi-class classification is where we look at the probabilities across three or more classes. So let's say you have 7 different personae and you want to be able to predict which persona an incoming customer is. That could be a multi-class problem and a prediction. Say you had 48 different trip types that you want to predict and you're a major retailer, and you can learn from product histories and visitation and events and behaviors about which trip type a particular person is on when they walk in the store. That becomes a multinomial, question. You've got 10 different offers. You've sent those offers out before. You've gotten some response back. You've validated. You've figured out what that positive response is. Now you can predict for new customers which of those 10 offers you should send and the probabilities of each of those to be responded by that customer. That's a multi-class problem, right? So binary, yes, no, right? Multi-class, yes, no, maybe. Another multi-class challenge could be predicting lifetime value or high, medium, low lifetime value customers. You can learn from the past to predict the probability of a customer to be a high value customer in the future. Regression, which many of you who've studied analytics have seen in linear approaches, can also be done with nonlinear approaches. So regression is where we're predicting a next period value. It's predicting a value, continuous variable. And we can do that using obviously more than just integers and reals. And then time series forecasting, another interesting capability of Squark, is where we factor in seasonality. So in regression, we may factor dates and look at the constituent parts of a date to use it, but a true classical time seriesist would not agree with that approach for factoring in seasonality in past events, whereas our time series forecasting factors in, the seasonality and the auto regression. Therefore, with regression, we predict one period into the future or one number. With forecasting, end periods that you define. And so most business questions that you want to ask from a predictive capability can be thought of into these 4 model classes. Binary, yes or no, is this going to happen? Multi-class, which of these things are going to happen? Regression, how much? Forecasting, how much for how long? So I want you to think of that. If there's one thing that you can take away today at a generalized level about AutoML is an understanding of these model classes and how from a macro perspective, you can fit various business use cases, well outside of marketing, I might add, into them.